Testing 1, 2. Okay, in this video we are doing the Reteach to build understanding on writing proofs. So they're giving us what we call a flow proof here, flow chart proof. It kind of shows how things are linked together. It's a flow proof. And they want us to write a 2-column proof from this. So let's look at the reasoning in this. So we're given that angle 1 and angle 2 are vertical angles with each other. So we can see that. And we can also see that 1 and 3 together makes a straight angle, which is 180 degrees. And we can see that 2 and 4 together also makes a straight angle, which is 180 degrees. So this is an idea of congruent supplements. We have 2 angles that are supplementary with 1 and 3, and 2 that are supplementary with 2 and 4. But angle 1 and angle 2 is shared between both of those. So that leaves angle 3 congruent to angle 4, which we also could have got because angle 3 and angle 4 are vertical angles also. So on this one, we want to prove that angle 1 is congruent to angle 2. So we're not assuming that they're congruent, but we just see that they're vertical angles. And then after this, once we prove that they're congruent, we can say that vertical angles are congruent. So this basically proves that since 1 and 2 are vertical angles, that they end up being congruent to each other. So let's see how this proof needs to go. So we need to supply the missing reasons. So 1 and 2 are vertical angles. That's going to be given. Now measure of 1 plus 3 equals 180. And 2 plus 3 makes 180. So 1 and 3 makes 180. And 2 and 3 also makes 180 going this way. And that's definition of supplementary. It also could be linear pairs of angles are supplementary. So linear pairs are supplementary. So either one of these would work for a reason for step 2. Now, since 180 is equal to 180, we can substitute and say that these are equal to each other. So in the middle here, we kind of have the idea that 180 is equal to 180. This 1 and 3 is going to get substituted in for the 180 on the left, and the 2 and the 3 get substituted for the 180 on the right. So this is going to be substitution. And I could make a note 180 equals 180. Don't have to do that, but it just helps me like come back later and see what I was thinking about when I did this. Okay, so if we look at step 4, we can see that angle 3 has been taken away from both sides. So that leaves us with measure of angle 1 equal to the measure of angle 2. That's subtraction property of equality. We subtracted measure of angle 3 from both sides. So sometimes you can abbreviate POE for property of equality, but it's subtraction property of equality. And since the measure of angle 1 is equal to the measure of angle 2, by definition of congruence, we can say that angle 1 is congruent to angle 2. And that's definition of congruence. Definition of congruence. And we're done with that proof. Let's look at the next one. Write a 2-column proof of the right angle congruence theorem. So this is going to show that since these 2 angles are right angles, they have measures equal to 90. And since 90 is equal to 90, it leaves these 2 angles equal to each other in their measures, which means that they're going to be congruent to each other. So let's see how this proof needs to go. So angle 1 and angle 2 are right angles. So angle 1 and angle 2 are right angles. So angle C we'll call angle 1, angle D we'll call angle 2. So this is going to be definition of right angle. And also by definition, we can say, right angles measure 90, I guess. So right angles measure 90 degrees. Now we've got 90 is equal to 90, which leaves, substitution-wise, C in for the left 90, D in for the right 90, leaves measure of C equal to D. So this is going to be substitution. Property of equality, POE, and we could, as a reference, say 90 is equal to 90. And since these two are equal to each other in measure, then they're going to be congruent to each other. So this is going to be definition of congruent. If two angles have equal measures, then they're congruent.